just so you can go back to it if you need to later. Okay, suppose the demand and the price of strawberries is related by P, and P is price in dollars, is equal to D of Q, the demand for Q units of strawberries, and Q is the quantity demanded in hundreds of quarts. It's important to notice the units on Q, because the units is hundreds of quarts. So if you get an answer like 5, that's not 5 quarts, that's 500 quarts of strawberries. And Q is the quantity. Find the price at each level of demand. Now you're used to having functions like f of x is equal, or maybe we need to actually talk about function notation in case you haven't watched all the videos. There's things called functions. Functions, if they are linear, follow the format y equals mx plus b, where m is the slope. B tells us the y-intercept is 0, b. And in functions, x is called the independent variable. Now, there's no reason that it has to be x. That supply and demand function we just looked at is also a linear function, and it has these parts. Y is called the dependent variable. And that's because once you choose a value for x and multiply it by m and then add b, that determines what y is going to be. And for any value of x in a linear function, once you plug in x, there can be only one y answer. If you do the math right, there's only going to be one y value comes out of that equation when you plug in an x number. Now, in order to actually explicitly say this is a function, we say it's f of x. And that's read f, or a function of x. Or some people say a function in x, but that doesn't make as much sense to me. I prefer a function of x, because what comes out of the equation is a function of what you put in the equation for x. So f of x equals mx plus b is a linear function. Now, linear functions can be written other ways, and they don't always have f of x notation. For example, 2x minus 3y equals 6 is a linear function. Okay? It is a linear function, because if you choose a value for x, in order to make negative 3y be 6, y is going to have a specific number it has to take on. And we don't usually substitute for y, we usually substitute. There's also the fact that we can solve this function for y by subtracting 2x from both sides, and then divide everything by 3, negative 3. I'm sorry, that's a y. It's a really bad looking y, but it's a y. So then y is going to be equal to, these 3's cancel, negative 2 over negative 3 is going to be 2/3 x, and 6 over negative 3 is going to be negative 2. So it looks like this, except that y can be written as f of x. That's the only difference. Okay? Now, the variables do not have to be x and y. The variables can also be letters like p, Q, R, S, T, U, V, W, X, Y, or even Z. We can use any of the letters at the end of the alphabet for the X and the Y in the function. So in the case that we're looking at in this example, we're using Q as the X value, and we're using P as the Y value. Okay? The price is a function of the quantity. How many you're willing to buy is a function of the quantity. Or, I'm sorry, how many you're willing to buy tells you how much you're willing to pay. Said that wrong. So if you know how many you're willing to buy, then there's going to be a certain price you're willing to pay for the number you're wanting to buy. Same thing with the supplier. For a certain price, they have to be willing to make that quantity to set that price. So with that background, let's work on this problem. This will take you through all the concepts that you need to learn in this chapter. First of all, we're only going to talk about supply. I'm sorry, we're going to talk about demand. Demand, because this is the quantity demanded. So we're talking about demand. This is your end of things. This is the consumer that we're talking about. Because they set demand. So if this is the function for demand, D of Q equals 5 minus negative 0.2, or 5 minus 0.25Q. If find the demand for Q quarts, that tells you that the value of Q is equal to 0. And you want to find the demand for Q, with Q being 0. And since negative 0.25 times 0, or even just 0.25 times 0 is 0, then the demand, when there's 0 quarts to be had, is $5. Okay? So if there's 0 quarts out there, but we want strawberries, we'd be willing to pay $5. But there's no strawberries to be had. Okay? Now if there's 400 quarts available, D of 400 quarts is equal to 5 minus 0.25 times 400. And 0.25 times 400 is 100. And demand is actually negative. At a price of $5, we're not interested in buying straw, or at a price of, when there's 400 quarts available, we're not interested in paying for them. Now think about this. This is the demand for, let's say, every Walmart in the country. And between every Walmart in the country, there's 400 strawberries. Are you likely even going to be able to buy strawberries? Regardless of what the price is at those Walmarts, there's only 400 nationwide, collectively, in Walmart stores. That means not even all Walmart stores have them. Are you going to want to buy them if they're not even there? No. So a negative demand just says they're not available. I can't buy. What if there's 840 quarts? Well, that's going to get even worse. If it's 840 quarts, then 0.25 times 840, and I'm going to haul out my calculator now because my brain's not that sharp yet. So that's 5 minus 210. And actually that's 840 hundred quarts. So this was actually 400 times 100. And that would have been 40,000. But even if there were 40,000 quarts in all Walmarts across the country, there's still going to be Walmarts that don't have any strawberries. Okay?
I have a question.
Yes.
If, say there are a question like this is on the test, do we need to multiply the ending answer by 100 and 700?
Yes, to actually answer the question. When we come toward the end, I'm going to have you do that.
Okay, thank you.
So 5 minus 210 means that we're even less willing to buy them, actually, because we're even less willing to find them. Okay? So that's the demand for these amounts that are available. Now, this one is a little more logical, and it's going to make a little more sense to you. This says, find the quantity demanded at each one of these prices. So if the price is equal to $4.50 a quart, then D of Q is $4.50. And the formula is still 5 minus 0.25 Q. This time we're not looking to find out what the demand is. We're trying to figure out what is if they're $4.50 for the price, how many would we buy? Right? Well, 450 minus 5 leaves us with negative 50 cents. And that's equal to negative 0.25 Q. If we divide negative 0.25 into both sides, then that tells us the quantity is negative 0.25 and a negative 0.50 is 2. So now we're going to talk about what does that mean. Well, that means at a price of $4.50 per quart, then the demand is 200 quarts. Not 2 quarts, 200 quarts. So this may be the supply and demand for a particular store. Okay? So if the manager orders in strawberries and he's going to sell them for $4.50 a quart, he can expect to sell about 200 quarts. Okay? Now, if the price drops a little bit to $3.25, the price is $3.25 per quart, we want to find the demand, or in other words, how many quantities, when the demand for that quantity causes a price of $3.25. So in this case, again, we would divide both sides, or we would subtract 5 from both sides. And 325 minus 5 is negative $1.75. I'll double check, but I'm pretty sure I did that right. Okay, and then that negative $1.75 divided by negative 0.25 that's going to be positive, and Q turns out to be 7. So what that means then is, at a price of $3.25 a quart, a cheaper price, by the way, price went down, the demand will be 700 quarts. Remembering that Q is actually measured in hundreds of quarts. Okay? Now work with the people around you, and I want you to find for me, just to make sure we all know what we're doing here. If the price is $2.40, what happens? How many will be demanded when the price is $2.40? Your turn.
Yeah, I have a question. So for here, we changed the 2 to 200. And the 7 700. So what makes us not change like this to 4?
Yes.
And that's
Had
what
to be first to
whenever we plug it in.
Because we're saying
and then
that Q is in hundreds of quarts, but the actual value of Q is for, well, actually, let me back up. Yeah, we probably should have done that.
I was going to say, if I get a decimal number, do I have to put a decimal number?
No,
Or just put it as decimal?
keep your decimal. But remember, that's a decimal times 100 if we're talking about demand. And I just realized I made a mistake, so we're going to back up on part A, because my brain just was, I didn't finish my cup of coffee before I came in. I should have. Let's go ahead and take care of this one first, and then I'll back up. So now your turn, you tell me, if the price is $2.40, how many hundred quarts will be demanded?
Shelby Simon for 1-1?
Let me look all this.
Because when I did it, I took a screenshot with my iPad and then uploaded it from my library.
Okay. Let me just look. Yeah, well, yeah,
Okay.
because you typed your answers in, right?
Yes, ma'am.
Okay. Yep, it's all there. Now here's the problem, but, Caleb, here's the problem. All you typed in was the answers.
Oh,
You're trying to get
I gave you the answers.
yeah. And then you
I want to see how
you got to
how you got the answers. That's right. So you're gonna have, you need to go in there and fix that, and you still can. Okay? Anybody that did 1.1, I haven't looked yet, you can still go fix this. Just a word to the wise, 1.1, I gave you the answers. I'm not going to give you any credit to tell me the answers.
because you already know.
I already know the answers. I told you the answers. Show me how you got from the problem to the answer. I want to see the work. You did not look at that problem and say, no, okay, this is the answer. It did not come to you through divine revelation or a vision. Okay? You had to actually do something. Show me what you did. Yes, ma'am.
So on the third question that you made us it said like the equation is one thing and then K gets to a different equation. Is that on purpose or is there a miss?
Completely different equation. What did we get there? What did we get there? Because I'll need to tell everybody, you're not going to be the only ones that want to know. Okay, has everybody got the answer to the one we were working on? 1,040. So you came up with, for 240 being the price, you got Q was actually equal to 2.4. But then your answer is 2.4 times 100 is 240.
We got 10.
10.4.
Not 2.
Okay, 10.4?
Yes, ma'am.
How many people got 10.4?
We just multiply that.
Okay, but 10.4 multiplied by 100 is
1,040.
1,040.
That's what I said.
Okay, I'm sorry, I misheard you. My bad. My bad. Okay, does that make sense to everybody? Okay, for some people that were confused a minute ago, and I'm sure there were some people who were confused, because I messed up big time. Go back to problem A. What I told you for Q of 0, yeah, that was right. The demand at Q0, well, they would have paid $5, but there weren't any available. Okay? However, I messed up royally on the others because my brain did not go, oh wait, Q is in hundreds of quarts. So when it said 400 quarts, Q in hundreds of quarts, Q would have been 4 for 400 quarts. So what I should have done was D of Q equals 5 minus 0.25 Q. I should have been using 4, not 400. So that would have been 5 minus 0.25 times 4 is 1. So the demand, when there's 400 quarts available, should have been 5 minus 1 is 4, and that means that since D of Q is in dollars, because D of Q is equal to P, that would have been $4. $4 per quart. So if there were 400 quarts available, people would be willing to pay $4 a quart. So that was my bad. And similarly, if it was 840 quarts, then my demand that I should substitute in, 840 quarts, if I divide 840 by the 100, because it's in hundreds of quarts, Q should have been 8.4. Because 8.400 is 840. And in that case, that should have been 5 minus 0.25 times 8.4. So then the price, remember D of Q is equal to price, would have been $2.90 a quart. Okay? And I apologize for that, and I appreciate the person that points that out to me to let me know, and if you'll let me know after class, you get a +1 by your name on the class roll. When you catch me in something, I put a +1 by your name, and I have a little column in my grade book that says bonus points. And every time you get one, I'll raise your bonus points number by 1. Those bonus points numbers can be used pretty much any way you want them to. I will add those to any one assignment you want to add it to. That means you want to get those bonus points. Now, I'll only add them to 1. So your bonus points, say you get 10 throughout the semester, and you have a grade that was not close to what you wanted. You made a 75. You really would have liked to make better than that, but you got 10 bonus points at the end of the semester. I'll give you an 85 for your 75 when you trade in your bonus points.
On the following exam.
If you're passing at the point you take the final exam. Okay? I'll hedge a little on the final exam because I have to actually turn those results in as a departmental final. But yeah, up to a point. If you've actually passed it, yes. If you made at least a 65 on it, then I'll give you bonus points. Okay? And actually, if you made a 55, it wouldn't do you any good anyway. So, all right. So, do you understand how the work functions? And by my really royal screw up, you now know that you better pay attention to the words. So let's move to the next part, and then I've got one that I'm going to have y'all do. Suppose the price and supply, now this is the producer. We are now talking about the producer. The supply of strawberries is related by P is equal to S of Q, S being supply, Q and again being the quantity, is equal to 0.25 Q. Where P is the price in dollars and Q is the quantity supplied in hundreds of quarts. Find the quantity that they're willing to supply when the price is 0. Now, before we plug this in, if the price is 0 and you grow strawberries, how many strawberries are you going to grow? Yeah, I'm not going to plant those suckers, so I'm not going to be able to sell them for, at least some money. So logically, we know that when the price is 0, they're not going to grow any. That just makes sense. That's just good business sense. But what about if the price is $2? What that means is 0.25 Q is equal to 2. And if we divide both sides by 2, oh, I'm sorry, 0.25. Two divided by 0.25 is 8. So Q is equal to 8. But again, remember, Q is in hundreds of quarts. So if the price is $2 per quart, then the producer is going to supply 800 quarts. And once again, I'm going to ask you, what if the price is $4.50 per quart? How many would the producer be willing to supply? Yes, I know I skipped over the graph. We're going to go back to that. We're going to do them both at once. You get an answer, let me know.
Well, 878.
Say again?
I got 18 quarts, but then you said 878.
It's 1,800 quarts. Okay, can I get confirmation for that?
Yeah, I got those three.
Okay, everybody got 1,800, so the producer will supply. Q is 18, but then that's 1,800 quarts. So do I expect to see this sentence if I give you a problem like this on the test? Yep. Because I didn't ask you what Q was. I wanted you to answer the question. And the question was, find the supply or the quantity supplied at each price. And that requires a sentence. In no circumstances will you ever walk into your job and your boss hands you a sheet with 50 algebra equations on it and say, tell me what X is for all of these. You know logically that's not going to happen. They're going to ask you to look at some data and come up with a model and then answer a question that they need to know the answer to. It's going to be in words, it's not going to be just numbers. Okay? Now let's move back to part G for just a second. Because part G and part K are related. Part G says to graph P equals 5 minus 0.25 Q. Okay? I don't want you to hop immediately to the graph paper. This is what I want you to do first. Always use your calculator to help you out with this. Go to your calculator, press your Y equals key, and like me, you may or may not know what all that stuff is on there, so what we're going to do is clear it out. I want you to hit the clear key right there. I don't want any Y equals equations on here, so scroll up and scroll down and make sure there's no equations on Y equals. And then the other thing I want you to do is I want you to look across the top. Does anybody have a black box on any of the plot numbers? Okay, if you do, this is what there's two ways to do this, but you may forget the first one. If you do have black boxes, press your up arrow key and put your cursor on the one that has a black box. Press enter and move down. That black box will disappear. Your enter key on those things is like a light switch. If you put it on a box that's black and hit enter, it'll make the black go away. If you put it on one that's not blacked in and hit enter, it'll turn it black. So you want that screen to look just like this. Okay? You want anything on there. And then at Y1, I want you to enter the equation. Now, we do not have Q's and P's that your calculator understands that it can graph. Okay? It deals in X's and Y's. So you need to remember that Q is the X type value, the input value. And P then is going to be your Y value. Your calculator is going to distinguish these by this particular P is going to be Y1 because we're going to put it in at Y1. Okay? So at Y1, we're going to enter 5 subtract. Be sure you use your subtraction key. That's this one. This is your negative sign. That's your subtraction sign. They are not the same. Your calculator will complain bitterly and give you wrong answers if you mix them up. So remember, this is negative, this is subtract. So 5 minus 0.25x. Okay?
So Q is the Q's the X,
Q is the X,
P equals the Y.
P's always gonna be the Y. Okay?
But you only have one equation.
Now, normally, if you're only gonna graph one equation, I would have you set up the window and graph that one equation by itself. But since we're also going to have to do another one, we're going to do both these at once. Which is why I waited till now. So then I want you to also complete part K. And it says graph P equals 0.75 Q on the same axis used for part G. Well, may as well do it all at once then. So P, this is actually going to have to go in Y2 because we've already used up Y1. And Q again is going to be X. So at Y2, enter 0.75 X. Am I good with that one? Okay. You can just hit graph, but you have no idea what your calculator's been doing last. You need to kind of figure out a window to graph on. In other words, what we're about to do now is the calculator equivalent of taking this piece of graph paper and trying to figure out how to draw the X and Y axes. So before we get started, I'm going to ask you some questions. Is the price, either for supply or demand, either one, is the price ever realistically going to be negative? No. You can't tell the store, that, you pay me because you didn't have any strawberries. Because they're going to say, sorry about that, but I'm not paying you because I didn't have what you wanted. So, no, the price is never going to be negative. Is the quantity that you can buy or the supplier can produce, is that ever going to be negative? What's the least number that the supplier can produce? 0. They just don't ship any. They don't have any invoice that says, I shipped negative 2,000 quarts to Walmart last week. No. That doesn't make any sense. Okay, and are you ever going to be able to buy negative strawberries? No, the least you can do is not buy them, and that's 0. So the thing is, that gives us a place to start. It's going to give us a way to start our window, because what we just decided by what you told me.
What did you just say about?
I just hit Y equals. On the graph paper, this is what we've decided. And we're going to work back and forth between calculator and graph paper on this. On the graph paper, we have made the decision that when we graph this equation, that it doesn't make any sense to look at anything but the first quadrant. So we really don't care anything about what's going on over here or down here because it isn't relevant to an application problem. It doesn't make any sense to an application problem. So remembering that our x-axis is Q, quantity, we're going to label it that way. going to come down here and say this is quantity in hundreds of quarts. Because that's what it is. And then on my graph paper, P is actually Y, and it's either going to be S of Q or D of Q. So I'm going to put both of these up here because both of them are Y. So your Y-axis is both demand and supply. And the way that it's measured is the price in dollars per quart. Okay? There's what my graph looks like right now. Notice I haven't scaled it. We're going to use the calculator to help us figure out how to scale it. Okay? We know that X minimum value is 0 because it doesn't make any sense that we could have less than 100 quarts.
How do we get to that X?
Window.
Okay.
Okay? Change your X to 0. Don't worry about the maximums right now. I'm going to show you how to figure those out. Scroll down, and your minimum price per quart, the least that's going to be is going to be 0. Okay?
That's your Y.
That's your Y, the minimum value for Y. That's basically telling your calculator, I only want to see the first quadrant. I don't want to see any negative numbers for X or Y, either one, because they don't make any sense in my problem. Okay? Now I want you to kind of look back over what we've already seen. The kind of prices that we've been looking at have been $4.50, $2.40, $3.25, $0, $2, $4.50. I want you to imagine if it is the middle of dead winter and you are dying for strawberries, what's the most you would be willing to pay? You are a strawberry freak. You love strawberries and you're not eating frozen ones. You need strawberries. It's Valentine's Day and your sweetie wants chocolate-covered fresh strawberries. What's the most you're going to be willing to pay for those strawberries? Who thinks they've got the highest price? Would you pay $25? Anybody? No, I don't love anybody that much, not even myself. Would you pay $10? I might pay $10 for a quart of strawberries. Maybe. I mean, I'd have to be really, really desperate. It would have to be somebody I really, 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 really loved.
It'd have to be some good strawberries, too.
It'd have to be some good strawberries. Those suckers better be bright red and juicy and beautiful, right?
Huge strawberries.
Huge strawberries. So I might pay $10, okay? So what I want you to, what I'm trying to get you to do here, this is an application problem. We are not talking about a math problem. We're talking about a real situation, okay? If the most I would pay is $10, and Y represents the price, then the most I'm going to put in for Y is going to be $10 because I am not paying more than $10. That's it. Okay? Just not happening.
Oh, that's your Y max?
That's your Y max, not your X max. Because your X is how many quarts of strawberries. Now, personally, if it was going to be $10, the most I'd want to buy is 1 quart. But the supplier would say, hot dog, there's some food that'll pay $10. Maybe there's some more of them. So they're going to produce a lot more than one if it's $10 a quart, right? We don't know how much the producer's willing to supply. So we're going to be kind of arbitrary, knowing that the producer's cost is going to go uphill. The producer's willingness is going uphill. He's going to supply more and more as the price goes up. So what we're going to do is we're going to assume that the producer, since the kind of numbers that we've been looking at here are 800 quarts and 200 quarts, we're going to suppose that he might be willing to supply 1,000 quarts, just arbitrarily. Maybe 1,000 quarts. Because that means Q would be what? What's 1,000 in terms of hundreds? How many hundreds is 1,000? 10. Now this is all just arbitrary. We are not saying that this is necessarily the right window, but this is just a place to start. Now what I'm going to do is I'm going to hit graph. And I lucked out. I'm going to be honest with you right now, up front, I lucked out. I lucked out because I actually got a window that's pretty decent. If you don't, what you should at least get is you should see where the cross is. You should see where those two intersect. As long as you get a window where you can see where they intersect, you're good. You're golden. If I hadn't done that properly to begin with, here's two things that could have happened. Don't follow me, just watch. I could have thought that they would supply a lot less than that, like maybe 500. And then I would just barely see where they cross. So that tells me that I didn't go far enough on the x-axis, so I need to go higher than that. Now, if I had gotten really excited and thought that they might want to supply 2,500 quarts, which actually I don't need those zeros, so let me back them out. My graph would have looked like this, and notice that everything that's happening is happening back here. Now my point here is nobody magically knows how to set that window up. You have to be willing to play with it. So try to think through the application and think what might be reasonable. But once you see where that cross is, and actually it's more important that you figure out a reasonable X value than it is a Y value. Let's see, maybe 800 works good. The other thing that you can do is you can also hit your zoom button once you, now you do have to set your X values to something for this to work. You have to set your X from 0 for the minimum to something for the maximum. You do have to set your X values. But then what you can do once you've set those X values is you hit your zoom button and you can scroll down to 0, which is zoom fit. And it will choose a window that guarantees you're going to see both X and Y. Okay? So this is what our graph looks like, but we still have to be able to put it on paper. So here's what I want you to do. These are the important parts of the graph. You want to know what the X and Y intercepts are. The y-intercept is where x is equal to 0. You can tell it from the equation, but you can also tell it from the calculator. The calculator says for that upper equation that the y-intercept is at y equals 5, 0, 5. So what I'm going to do on my graph here is go, this is 0, here's 1, 2, 3, 4, 5. So and looking at what y1 is my demand equation, all right? Yes, my demand equation. That y-intercept is 0, 5. And that's going to go with the demand equation. Now, since I also want to make the most efficient use of my window that I'm at, I'm already at x equals 0. I might know that it's 0, 0 for the other one, but if I don't, then I just use my down arrow and hop to the other one. S of Q is going to be the supply equation, and its intercept is 0, 0. The other most important point on this graph is where do those two lines intersect? Okay? Where do those two lines intersect? Because once I know where they intersect, I can draw both lines, no problem. So what I want to do now is I want to go back to second and trace. It's called the calculate menu. It shows you points on your graph. And let's go down to number 5, which says intersect. Okay? Go down and choose number 5, which says intersect. Hit enter. And before you do anything else, I want you to use your right arrow key. And I want you to move closer to the intersection point.
I'm right by the intersection. It's almost
Okay, as
like
long as you're
by-
right by it, but if you're not, see mine came up right there at the Y intercepts. So if you're not close to it, move your cursor close to it, and then all you have to do, you don't really need to pay any attention to this, hit enter 3 times. And it says the intersection point is 5, 3.75.
On our graph, do you want us to put in hundreds, 100, 200, 300, or 1, 2, 3, 4, 5 on the
Okay,
x-axis?
because of the way I labeled mine, because I said it's the quantity in hundreds, so this
Okay.
is going to be 1, 2, 3, 4, 5, because that makes it easier. That's why I want you to label your axis. It makes it loads easier if you do that. So then, since this is quantities in hundred, and I know I need to see 3.75. This is going to be 1. This is going to be 2, 3, 4, 5, and 3.75. Okay, this is 3.5 because there's 1, 2, 3, 4, 5. So this is 3.2, 3.4, 3.6, 3.8, 4. So this is 3.5. This is 3.6. This is 3.8. It's going to be a little closer to 8 than it is
But
to 6.
this is an x5. That's
Oh, yes. Sorry, thank you for reining me in. Okay, so X is 5. X is 5. Y is 3.75. So here's 1, 2, 3, 4. 350 is about there. This is 360. This is 380. So 375 will be pretty close to right here. Because that's your dollars. And this is your 500 quarts. So what we're going to do is we're going to use the ruler to help us make sure we get to the right place. 3.75 up. And 5 across. Tells me that my intersection point on my graph is 53.75. And that is a point that is both on the demand equation and it's on the supply equation. So here's my supply graph. Here's my demand graph. And I see everything that I need to see. There's what your graph should look like. Okay? It says find the equilibrium quantity and the equilibrium price. You can answer that right on the graph. Remember, that's 500 quarts. Demanded and supplied at $3.75 per quart. Now, before you go to bed tonight, if you notice, there's another problem on there. And again, I brought graph paper, so nobody needs to print it out. If you're using your iPad, I put a sheet of graph paper up there. You can download it and upload another one if you need to. It's blank. But this is for you to do on the next page. Let supply and demand functions for butter pecan ice cream be given by these. Where P is the price in dollars and Q is the number of 10-gallon tubs of ice cream. Graph those on the same axes. Find the equilibrium quantity and the equilibrium price, and then they give you a hint. The way to divide by a fraction is to multiply by its reciprocal. Okay? So if you want to get rid of that 2/5 in front of Q, you need to multiply both sides by 5/2. Right. That's a good way to remember that. That's your homework assignment. I will grade those. I will also go ahead and upload an extra piece of graph paper in Shovie in case somebody needs that extra piece.
So we need to take a picture and put all these in on Shovie.
You can take a picture if you did not work it straight in Shovie.
So we need to do that though?
What we did in class.
Yes, well, actually, do that for what you did in class, but then I want to see that other problem too.
Well, yeah, you want to see the whole handout.
The whole handout. That's a homework grade.
And then also, 1.2 is due today.
Yes.
Just the homework, right?
Just the homework, just to show me homework. I will look at your notes.
I was I took, on my math 5, I was late, and I didn't do 1.2. And I still do that late. It said I needed a password.
Rather than give you the password, even though it is on the calendar, let me go in and just adjust the due dates for all of chapter 1's homework and in my math lab so that nobody will be trying to get in late. Because this first couple of weeks for chapter 1, I'm not sure what the due dates need to be, so I just put something in there that I know.
You're gonna reopen on Pearson?
Yes.
Okay, I came up to your office, you're gone again, I need to sit down. I think it's the letters that throw me off, if I can get the function straight in my mind, I mean, I can do the math.
since your class schedule and mine are kind of at odds with each other, and even if you come by at 10, you know, there's not a whole lot we can get done from 10 till.
I need a bag where I can sit.
Yeah. Until you can see me, go to the Learning Center and ask Miss Perry, because they've got some good tutors.
Well,
plus
I
she
went
can
down
help
there
you.
before class when you were in there, but I mean, they got people in there all the time. If I could get in there, you know, but
Well, ask her for a time when there's probably not a lot of students there. And I'm sure she can tell you what that is.
she told me it was early morning, but I got class.
Have you tried for trio? Because you should be able to get.
They don't have any tutor. I'm working with Wendy. I worked with Wendy yesterday.
Okay.
I mean, it takes me 20 minutes to do a problem.
Let me go in and talk to the trio people and see if I can hook them up with tutors. Let me see if they're gonna be able to hire any.
Okay.
Okay, so on one of the Shelby reassurance, I know there's the answers, but I didn't understand how to do one of the last problems. And I sent you a comment, and we didn't have time to do it today. So is there any way, because it's due tonight, can you like,
If it's late and you don't get it done tonight, I don't count off on the first chapter for Shelby. The Shelby, if it's late, it's late. It just, the big thing about it being late in Shelby is I'll usually go in a day or two after it's due and grade everything. And then if I go in again, I know that I've graded everybody's that it said on time. But then I'll go and check the ones that it tells me turned it in late. Because late in Shelby is like 11:56 instead of 11:55.
yeah.
So, and it doesn't matter if it's 11:56 or if it's 5 days later, it still just shows me a little red clock.
Well, I haven't turned anything late, so I don't know why it's showing a clock, but,
Okay. What it does is if you turn it in even 1 minute late.
well, I don't even stay up that late. I'm in bed by that time, so I just push done and it should be.
Yeah,
turned
and
in.
if you ever need to, go ahead and turn in what you've got and then make a comment, say, I don't know how to do this problem, can you help me?
Okay, sounds good.
Okay,
And then,
because then it triggers an email to me that says, this student's made a comment on her assignment.
Okay. And then also you said to tell you about the point for the,
Yes, please do.
not trying to be,
No, tell me so I can write it
it's
down.
Peyton Hammett. Yes, ma'am.
I'm glad you told me because I would have forgotten.
No, you're fine. I do that too. We're human. Thank you.
And I didn't take roll today, so I didn't have a roll to put it on. I
Yeah,
would put
so
it
you're
on right
fine.
then.
Thank you.
Thank you.